Dragon is in countdown. Falcon 9 is in startup. Dragon, SpaceX, go for launch.
You are looking live at Launch Complex 39A at Kennedy Space Center. We are just about 24 minutes away from liftoff of this Falcon 9 for the 26th commercial resupply services mission from both NASA and SpaceX to the International Space Station. Good afternoon and welcome to live coverage of CRS-26. I'm Jasmine Hopkins with NASA Communications. Fueling of the Falcon 9 rocket began about 10 minutes ago, and we are counting down to an instantaneous launch at 3:54 p.m. Eastern Time. This mission will deliver more than 7,700 pounds of food, supplies, and science to the space station. This includes a pair of rollout solar arrays to power the orbiting laboratory and tomato plant seeds for the continuous fresh food production system on station. These resupply missions help NASA and our partners continue research that could better our life right here on Earth and help us explore deep space. Let's go now to SpaceX headquarters in Hawthorne, California, where Jesse Anderson is standing by to tell us more about the rocket supporting today's resupply mission. How are things looking, Jesse?
Awesome. Thank you, Jasmine. Hi, everyone. My name is Jesse Anderson, and I'm a production and engineering manager here at SpaceX. It's great to be covering today's mission in partnership with NASA. The rocket that you see on your screen is brand new. The Falcon 9 and Dragon spacecraft will be flying for the first time on today's mission. So far this year, we've launched 4 Dragon missions: Crew 4, Crew 5, Axiom 1, and CRS-25. Today's launch marks SpaceX's 5th Dragon launch of 2022 and our final Dragon mission this year. Now back to the rocket that you see on your screen. Above Falcon 9 is the Dragon spacecraft sitting at the very top. Now, as I mentioned previously, the Dragon you're seeing on the screen will be embarking on its first flight and will be joining the Crew 5 spacecraft already docked at station. Moving down, we have Falcon 9, our reusable 2-stage rocket. Falcon 9 is actually 2 rockets in one. The lower part, also the largest part of the rocket, is called the first stage. The smaller stage above the first stage and the black inner stage is called the second stage. Not only does SpaceX's second stage look similar to the first stage, it also has the same diameter, uses the same metal in the tanks, same computers, same propellant, and nearly the same engine. This allows us to use similar tooling, design, and systems to essentially build 2 rockets that are more reliable. Now above the first stage and black inner stage is our second stage. The stages will separate about 2.5 minutes into flight, and then the second stage will ignite its MVAC engine, which is the 10th engine on the rocket, to carry Dragon to its desired orbit. Moving down the rocket, the bottom of the first stage has 9 Merlin 1D engines, hence the name Falcon 9. These engines accelerate the vehicle through the Earth's atmosphere and into various orbits in space. And we will be attempting to recover this first stage on our drone ship, which you see there on your screen, named Just Read the Instructions. Just Read the Instructions is currently positioned off the coast of Florida in the Atlantic Ocean. But for now, let's turn it back over to you, Jasmine.
Thank you, Jesse. In addition to SpaceX in California, NASA teams both here in Florida and Texas are also monitoring today's launch. You'll hear from Dan Hewitt inside Mission Control Houston. But first, let's check in with NASA's Megan Cruz, who's monitoring the launch team here at Kennedy. Megan?
Thank you, Jasmine, and welcome everyone into Hangar AE at nearby Cape Canaveral Space Force Station, where the U.S. Space Force monitors the range for us, making sure it's safe to fly where we want to fly, but also the weather, which is better than it had been a few hours ago, but still not looking great. And this is why. Take a look. So the launch weather officer was predicting a 10% chance of go today. We are now at a 30% chance of go. So again, an improvement. But if we take another live look at the pad, I'll explain to you why there are still some concerns. So as you can see, very, very cloudy. There's still rain coming down at the pad, and it's conditions like these that are concerning because of the likelihood to trigger lightning. And lightning can cause serious damage to the rocket, which could in turn endanger the public. But the launch team is hoping for a break in the weather, and that's why the team went ahead with fueling the rocket at around T-minus 35 minutes today. Remember, they would need a break in the weather at exactly when we have our instantaneous launch opportunity at 3:54 and 3 seconds if we want to dock with the International Space Station tomorrow morning. So we'll of course continue to monitor the weather, but for now let's send it over to Dan Hewitt inside of NASA's Mission Control Center in Houston.
Hey, thanks so much, Megan, and everybody welcome to the International Space Station Flight Control Room here in Houston at the Johnson Space Center. So the people behind me, these are the ones literally flying the space station. They're working in concert with control rooms all around the globe to support the orbiting laboratory. Mike Lammers is the flight director in the room right now leading everybody, and he actually pulled the entire international team a couple hours ago to get their go for launch today. So we're also going to be watching the weather, but everything on space station is ready to go for this cargo mission. We have 7 crew members on board right now, 3 Americans, 3 Russians, and 1 Japanese astronaut, and 2 of our Americans, Josh Cassada and Nicole Mann, are going to be primed for monitoring Dragon's arrival. So with the launch day, we're looking at about 2 days to rendezvous and dock, heading to the space-facing side of the Node 2 Harmony module. That'll give us 2 Dragons on board, and this will kick off about a month and a half of really intensive cargo operations on the space station. So fingers crossed for the weather. We're going to keep watching, and we'll be ready for Dragon once it gets on orbit. But for now, I will send it back over to Jasmine at Kennedy.
Thank you so much to both Dan and Megan for those updates. We are now about T-minus 17 minutes and counting from liftoff of CRS-26. So let's get a closer look at some of the science flying on this mission. As more focus is put on exploring deep space, the risk of injury or unexpected medical surgeries increases. Here to tell us more about that is from the Suture in Space team, we have Monica Manici, biologist for the European Space Agency. Thank you so much for being here, Monica.
Thank you to you.
Of course, yes, we're so glad to have you. So we're going to talk about suture in space. You're the biologist on that team. Can you tell us how you think wounds will heal in microgravity on the space station?
Yes. Preliminary studies tell us that it is possible that the wound healing process is delayed and impaired in space. Wound healing is a very complex process with several steps strictly regulated in our organism. If even just one of these steps is altered, the whole process is impaired. So with this experiment, we hope to understand, at least in part, if and how weightlessness affects the steps of the healing process.
Right, and the healing process is very complex. And so how will the suture techniques in space differ from what we do here on Earth?
Suture interacts mechanically with our tissues because suture has to join the wound edges. Previous studies tell us that the network of proteins surrounding the cells in our tissues could undergo some changes in weightlessness, and also the mechanical properties of the tissues can change. Consequently, also the interaction between tissues and sutures could change. So this is an aspect that should be considered in the choice of the suture materials for space.
Right. Monica Minichi, thank you so much for joining us. Very fascinating things that you're doing.
Thank you.
Thank you. All right, another experiment on this resupply mission could help feed astronauts as they explore deep space in the future. That's where Veg-05 comes in. In this experiment, small tomato plant seeds are grown in 2 veggie chambers with different LED light conditions for 104 days. Then they are analyzed for how many tomatoes they grow and their nutritional composition. Station crew members will rate their flavor, texture, and juiciness. The ability to grow space food will help us reduce launch mass and improve quality for our meals for astronauts in the future. Earlier this month, some celebrity chefs even stopped by the Space Plant Production Lab right here at Kennedy. There on your screen, you see chefs Rocco DeSpirito, Duff Goldman, and Mark Murphy as they got an inside look at how food is grown in space while they were here for the Visitor Complex Taste of Space 2022 event. All right, now we are only about T-minus 12 minutes and counting from liftoff of the 26th Commercial Resupply Services mission from NASA and SpaceX to the International Space Station. Let's bring back now Jesse Anderson to tell us more about today's launch and Dragon.
Thanks, Jasmine. As we near the end of the year, today's mission marks SpaceX's 185th overall Falcon 9 launch and the 5th flight of Dragon to the International Space Station this year, following the launches of Crew 4, Crew 5, Axiom 1, and CRS-25. Now, to give a bit of history, Dragon has been flying for 12 years. Dragon made its debut at the orbiting lab in 2012 as the first private spacecraft in history to visit the International Space Station. Since then, it's made 32 trips to and from the orbiting lab. Now, today, Dragon is one of the few vehicles that can deliver significant cargo to the space station and the only vehicle that can deliver cargo from it. Falcon 9 and Dragon were both designed with reflight in mind, and the vehicle hardware is built to support multiple missions with minimal refurbishment. Now, to date, 16 of our missions have flown on flight-proven Dragons. While today's launch marks the first flight for this particular Dragon and Falcon 9, we plan to recover and fly both the vehicle and spacecraft again in the future. So far, we've reflown first stages 126 times, and this includes Falcon 9 and Falcon Heavy flights. And we are planning to recover this one on our drone ship. Just read the instructions today. And if successful, it will mark the 153rd recovery of an orbital class rocket. We're now at T-minus 10 minutes and about 20 seconds until liftoff, with the range looking good. We are still tracking weather for an on-time launch today, so we'll turn it back over to you, Jasmine.
Thanks so much, Jesse. Now we're talking about going from the classroom to space. There are several student and university-led experiments on this mission, including 4 small satellites selected by NASA's CubeSat launch initiative, which gives students access to space. One of them is the Mario CubeSat from the University of Michigan, and it will test a material that could help improve the accuracy of space telescopes. Also on this mission is MIT's Black Box Extrusion project, which will explore how buildings and structures could be 3D printed in space in the future. Joining me now, we have 2 students from the universities we just mentioned. We have Jillian Haas from the University of Michigan. Thank you so much for being here, as well as Martin Nisser from MIT. We're so glad to have you guys here today.
Thank you for having us.
Thanks for having us.
Of course. So you guys are regular students, but you have something launching to space. How are you feeling, Jillian?
I'm so excited. It's incredible to have something that I worked on personally to be going to space very soon.
Right, it's really exciting. I can just see the excitement in your face too. Martin, let's talk about black box extrusion. You guys are using resin to 3D print in space. How does that work?
Yeah, so our ability to manufacture structures in space is really key to the success of sustainable, long-duration future space missions. But our problem right now is that any structures we launch to space have to be small enough to fit within the confines of a rocket fairing, and they have to be strong enough to actually survive the rigors of launch. So our team at the MIT Space Exploration Initiative have been working on a technology which will let us launch raw material in a highly compact liquid form, which we then solidify on orbit to manufacture space structures in space itself. And we hope that this technology will really address some of the fundamental challenges and constraints associated with launch mass and volume today.
Right, it's very complex. It's very exciting to see that you're working on that. Jillian, back to you. Mario is studying a very specific material in space. Can you tell us more about that and why was it selected?
Yeah, absolutely. So Mario is studying a piezoelectric material, which is a material that bends when a voltage is applied to it. So we selected to study it because we want to know how it degrades in a vacuum, essentially to test how it reacts to a space environment for future applications in space.
All right, that is fantastic. So I know that there's one last thing that each of you wanted to say to your universities. Go ahead. You can look at the screen and say it. We'll start with Jillian, and then we'll say it from you, Martin.
Go Blue and beat Ohio.
Go Blue. I guess I should say go Beavers, but yeah, thanks so much for the opportunity to both NASA and MIT, and we're looking forward to working on the project.
Fantastic. Go Blue, go Beavers. Very exciting to have our students here today. Thank you, guys.
Thank you.
All right, now we're going to talk about a boost in power. This resupply mission will increase the power on the space station with the addition of 2 new rollout solar arrays, also known as iROSAs. After being installed on an upcoming spacewalk, the arrays will roll out using stored kinetic energy, almost like a yoga mat. The iROSA is a new design that uses one piece of flexible material that snaps open in space. The first 2 iROSAs were installed last year, and after this set, there will be a 3rd set as well, totaling 6 iROSAs, which could increase power on the station by 20 to 30%. The rollout solar array technology isn't just for the space station. It is also planned for the Gateway Lunar Outpost, part of the Artemis deep space missions. All right, we are now heading to just about T-minus 6 minutes and counting until the liftoff of CRS-26. So let's bring back Jesse live at SpaceX headquarters in Hawthorne, California, and Megan here on Florida's Space Coast to walk us through the final moments of liftoff and countdown. Take it away.
Great, thank you, Jasmine. It is T-minus 6 minutes from T0, and the SpaceX team is working no significant issues. We are keeping an eye out for weather. We're currently only 30% go for launch, but the range remains ready to support launch today. As far as the vehicle, at this point, RP1 fuel is completely loaded on the 2nd stage and nearly complete on the 1st stage. Liquid oxygen loading is underway on both stages and will complete at T-minus 2 minutes to launch. We're also loading helium gas into both stages. Falcon 9 uses helium as a pressurant to backfill the propellant tanks as liquid oxygen and RP1 are consumed by the Merlin engines during ascent. Helium load began before the broadcast went live and will continue to top off until a minute and a half before launch.
To make sure engine startup goes well, we also perform what we call engine chill. This happens at T-minus 7 minutes, where we flowed a small amount of the super chilled LOX into the Merlin engine's turbopumps. We do this to avoid a thermal shock to the system when that full flow of super chilled liquid oxygen hits the prop system. Dragon also began its startup sequence at T-minus 35 minutes when it coordinated timing with Falcon 9. It's currently undergoing vehicle health checks with the next big step just before liftoff when Dragon transitions to internal battery power.
Now next up, the large truss structure next to Falcon 9, which is called the transporter erector, or what you'll hear called the strongback, will retract away from the rocket in preparation for liftoff. Before that happens, the clamp arms just below the Dragon that you see on your screen will begin to open. Once those are fully open, then the TE can begin to recline back. Now, in these last few minutes, Falcon 9 is performing final health checks on its primary communications, avionics, and propulsion systems in preparation for flight. And there you can see on your screen, those clamp arms that I mentioned are opening up.
Launch Director,
Again, once those are...
our launch weather officer has received his final set of data for today's launch attempt and is no-go for the opportunity. From a launch management standpoint, we will continue the count for the purposes of simplicity with our automation, and we'll stop at T-minus 60 seconds, at which time launch control will say the 3 magic words and end the launch attempt. So for now, clock will continue to count for an additional 2.5 minutes.
Sorry to pause there for a moment, folks. I was just listening to the launch team talking with the launch weather team to talk about the weather, and it does sound like we are going to scrub for the day. There are still 3 launch weather constraints that they have not been able to clear, and they don't think will clear by the time we hit
Stage 1,
T0.
lock load complete.
But as you can hear the call-outs, they're continuing with the countdown. And they're just going to let this countdown terminate on its own. So again, scrubbing for the day because of weather concerns that if we were to launch, it would trigger lightning, and that would be very dangerous for the vehicle. It could destroy things on the vehicle and in turn be a public safety risk. So again, weather being the cause of the scrub today. There are other backup opportunities, thankfully already. We have 2 on the range for Saturday, November 26th at 2:20 p.m. Eastern Time. Also Sunday, November 27th at 1:58 p.m. Eastern Time. Both of those days looking much better in terms of weather. I did speak to the launch weather officer for today. That's Mike McAleenan. And he did tell me that the percent go for those days are a lot better than today, the 30% go we had. On Saturday, the percent go is 60%, where Sunday it would be 40% go. So we have to wait a couple of days, but it seems like it'll be worth the wait. Again, you still hear those call-outs because we were going to let this countdown terminate.
Dragon is in auto idle.
But again, we are not going to attempt a launch today for the safety of the vehicle as well as the public. Now, when we launch, this will be the last Dragon launch of this year. We are bringing about 7,700 pounds of cargo, science, and supplies to the International Space Station. Some of the items include gym hardware for the astronauts, as well as some life support equipment, also medical equipment.
Hold, hold, hold.
And
Launch
there you
abort has
hear
started.
that call for hold, 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 launch abort has started. So that finally terminates the countdown, again in line with what has been decided earlier, which was that we will scrub because of weather. 3 launch weather constraints that could not be cleared in time for the instantaneous launch opportunity today at 3:54 and 3 seconds Eastern Time. Those rules are the cumulus cloud rule, the disturbed weather rule, and the flight through precipitation rule. Again, those rules could not be cleared by the time we wanted to launch at 3:54 and 3 seconds today. Another live look at the pad there. You can still see liquid oxygen venting off from both the first and second stages. And you saw that the countdown was stopped at T-minus 57 seconds. SpaceX and NASA will be standing down for the next couple of days. The next time we plan to try to launch CRS-26 is Saturday, November 26th. Again, the at last check for the weather on that day, we are 60% go, so a lot better of an opportunity there. The time for the launch on the 26th is 2:20 p.m. Eastern Time. If for whatever reason we don't launch on Saturday, November 26th, we're going to go to Sunday, November 27th, launching hopefully at 1:58 p.m. Eastern Time. So thank you so much for following along with the launch. That is the latest from the launch weather team. And again, a weather scrub for today, but we will try again in a couple of days. But for now, I'm Megan Cruz from Hangar AE over at Cape Canaveral Space Force Station. I'll send it back over to Jasmine at the host desk.
Thank you so much, Megan, for those updates. As we just heard, today's launch attempt has ended in a scrub due to weather. Our next attempt will be Saturday, November 26th at 2:20 p.m. Eastern Time. Live coverage will begin here on NASA TV at 2 p.m. You can also watch on the SpaceX webcast as well. We thank you so much for joining us. Hope you all have a good holiday, and we'll see you then.